Welcome, and this will be our lecture for today, this week, and um, working on looking at the reading, foundations of chemistry. There are three key concepts, and these will be highlighted on another page. I'll just go through them here. How can a change in energy affect the state of matter? What happens when something dissolves? What is meant by conservation of mass? Now, the conservation of mass, we're only mentioning it slightly. It's more important for the next unit, lesson 4. Okay, physical change. So last time it was physical properties like color, density, how you measure something. The physical change is a change in the size, shape, form, or state of matter in which the matter's identity stays the same. But again, physical features, all about how they look, how they feel. Change in shape, change in size. They use the example of pouring a juice from a bottle into a glass. You're changing its size, its shape, change in state of matter. Water is a good example because we know we can have water and ice, and obviously water and steam. And this shows it really well. We have a solid, all the atoms are closely packed together. Typically, this has the highest density. Water is an exception. Water actually, when it freezes, makes little holes, and so that's why water or ice floats when it freezes, because it has a lower density. But most of the time, the solid is going to have the highest density, and as you heat stuff up, it separates more. It can flow around until you get a very low density gas. The shape of the curve is important. You should notice that this is slightly less of an angle. This is a higher angle. And each substance is going to have a different curve. Now, these are all individual atoms. They're not shown as water molecules. So this curve does not look like the water curve because the water curve looks different. But you can see you got solid, melting, liquid, boiling, gas. And that's as you're adding thermal energy. On the next slide, it talks about removing thermal energy. And basically, removing thermal energy would be backwards. The temperatures, the boiling points, the melting points, all that stuff stays the same. It's just a matter of you're removing energy, not adding it. So, removing. Dissolving. So this is another separate concept. Dissolving is when you mix things. And again, the conservation of matter kind of shows up easier in the next slide. So if I have 5 grams of something, 150 grams of water, when I mix them, I'm not creating anything. I'm just adding 5 grams to 150 grams. So again, think of this as salt, water, salt water. And for the next unit, conservation of mass, we might have hydrogen here and oxygen here. They chemically react to make water. And to make this a balanced chemical equation, we're going to need 2 hydrogens. So we think of it, say 2/3 full. Let's say this is 1/3 full, and this is a full cup of water. But it's going to be a lot different because this is a gas state. It's actually going to be not. It's going to be 2/3. If it was steam, if everything stays steam, but that's a little bit confusing. You'll see a little bit later. All right. Just erase that. All right. And melting, what's the opposite of it? Freezing. Boiling, what's the opposite? Opposite of it is condensation. And deposition, opposite of it is sublimation. All right, so your vocabulary in one of your handouts was simple. And so there's those 3 key concepts again. And I made your vocabulary more exact, mentioning absolute 0, specific heat. So that's kind of those curves that I was showing earlier, like how steep they are. It's about how the specific heat, and heat of vaporization, heat of fusion. And then the yellows are adding energy, oil, liquid to gas, add energy. Melting, solid to liquid, you're adding energy. And then the blues are removing energy, so condense, gas to liquid, freeze, liquid to solid. Okay, so this is changing shape and changing state of matter. So size, shape, state. And basically it's still, you can think of this as still is water, but maybe it's the form of ice, liquid, or steam. Holding, like shape, putting firewood, changing its size and shape, melting, changing the state of matter, and release size. This is a tough one because it's size and shape, depending on how I'll put shape. So it's probably the size would still be the same. And again, this is not to be confused with burning, because when you burn a candle, actually it's a lot different. This is just melting it, so it's in a pot. You can think of it. Get a candle. The liquid inside. Okay, freezing water is state. Orange juice is shape. Cutting an apple is shape. So again, physical change in matter. All those examples above, any of those are good, or anything else. You know, and again, I always use water. It's still water. As long as you're not doing anything chemically with water, you can freeze it, you can melt it, you can boil it. It's still just water. No, unless you're cutting like the firewood. If you're cutting it up and giving it away, then you would be losing mass because you've sold it. But most of the time, when you break wood apart, it's still there. Maybe some of it might be really small. And this is, should be able to fill that out. Okay, to blank means to form a solution by mixing. So dissolving is a blank because the identity substance will not change. It's a physical. Blank is an example of solution that contains a dissolved substance. Salt water. Like many physical changes, dissolving is usually easy. Reverse, if you blank salt water, boil. Okay. And here's your quiz. So that brings us to the end of our presentation. It was useful.